afternoon. Thank you all very much for giving up a bit of your lunchtime to listen to what I've got to say. Thank you very much, Lyle, for the introduction and the invitation. Lack of productivity in construction cost the global economy $1.63 trillion every year. McKinsey research suggests that the main reason for this is underinvestment in digitalization as well as automation technology. We're actually the worst industry in the world, second only to hunting and agriculture for technology adoption. Highways England recently, I don't know if any of you would have seen this, published a report where they identified possible efficiency gains of 20% of their entire budget through better use of data. And the reason I mention this is because although we are focused on health and safety today, use of technology has got a huge amount of benefits across the construction and obviously infrastructure construction industries. So some specific highways testing issues which I'm going to identify. First thing is that obviously as an industry we're trying to put down as much material as possible in the most productive way. That means that often, and I'm speaking from experience here as a previous materials technician, you do find yourself stretched quite often to complete all of the tasks that are required of you in a given shift. The second problem is that it's actually a fairly dangerous job, and I'll get into why in a minute or so. Because we believe at HDS that the job of a materials technician is fairly easily automated, we think that there is almost an obligation on the industry to try and explore ways to do so, because by using more technology, we are going to be able to take people out of harm's way, put them into the safety of fans and the like, and reduce incidences on the network. A further problem worth noting is that we already struggle as an industry for qualified, trained people to work on our construction sites, and that's only going to get worse as we move into RIS2. HE have doubled their funding from government, and they've got a huge scale of construction that they're planning to undertake. HS2 is going to sap a lot of resources out of the highways industry, and other major projects like Hinkley Point C are going to put a further strain. So if we can redeploy workers who are already working in highways, doing materials testing, who have that materials knowledge to other areas, we'll be able to improve our health and safety, improve productivity, and hopefully save some money at the same time. Further point is that through better data collection, we do think that quality assurance information can be used in asset management. It goes to, well, it seems obvious to us that if you understand how a road was built, including, let's say, the quality of compaction, you should be able to make better predictions about how that road will perform over its life. But in order to do that, you need to collect data at a scale, which means that you can do the kind of analytics which unlock the value in that data. So these are some photos we took some time ago, pointing out what materials technicians typically do on site. This is someone taking a delivery temperature, and obviously they're interfacing with some pretty hot material there. Sticking your arm in the front of a hopper with 20 tons of black coming out the back of a 10-ton lorry is obviously not the safest thing to be doing. And there's a pretty significant crush risk, not only to your arm, but moving down the side of the paver. Sometimes you work in fairly restricted spaces against central reservations and the like. Taking people away from having to do that kind of a test, I think has got some fairly obvious health and safety benefits. Taking rolling temperatures, you're having to deal with rollers moving around. Sometimes visibility out of rollers is not the best. There have been a couple of instances both here in the UK and in Europe with unfortunately people on site being struck by rollers. So I think moving people away from having any interaction with material anywhere near rollers would be for the benefit of everyone. And other site vehicles on site, as you can see here, sometimes the whole lane isn't even separated by a cone. Materials technicians are often nipping about trying to get tests done whilst they're not keeping up with the paver doing lane records, and that means that they have to sometimes go into places which are not necessarily the most ideal areas for keeping safe. So if we can reduce people from having to go out and do this kind of spot testing, that will also be for the benefit of everyone. My particular gripe when I was a technician was doing rolling straight edge testing and sand patch testing. This is often done, well, it is always done at the end of a shift. You can sometimes be up to a kilometre or so away from the gang. You know, you maybe got the white liners around you, you maybe don't. You can't have your van following up behind you because you're out on your own walking up and down the length of the road that's been constructed. It's definitely not the safest place to be on a construction site, particularly if it's getting late and things are, there's perhaps a little bit of pressure to get the work done at the end of the evening and things start to move a little bit faster at the same time whilst everyone's a little bit tired. Again, site vehicles is something I'm going to refer to a few times here, but as technicians, we are often quite exposed to site vehicles, or even, you know, members of the public coming into the closure. Sand patch testing, crawling around on your hands and knees at 3 o'clock in the morning is not the safest thing to be doing on a road construction site. But we have people out there every night doing this testing with outdated equipment, you know, vials of sand and steel rulers, which, you know, to our minds is bonkers. Poor visibility when you're crouched down on the ground, meaning that you can't see potential hazards as they come towards you. And you're often the last people on site doing this because you have to wait for the material to cool down enough to be able to kneel down on it. We've actually had a couple of instances where TM has been taken off without letting the guy on site know. We've had live vehicles going past people that, you know, we employ on site, and that's, you know, something unacceptable. So any way that we can improve on these methods of testing through using technology will help us get people out of doing these old-fashioned and potentially quite dangerous forms of testing. This is something I wanted to talk about briefly. Obviously, in the name Highway Data Systems, we're very keen on looking at how we use data. This is a little image that I found on LinkedIn, and I have stolen, to be perfectly honest. But I think it's a good representation of how just having data isn't necessarily useful. You have to have a way of both sorting it, arranging it, and then if you can present it visually, you really can unlock some of the value behind it. This is some roller information that we took from the M25, and we've just simply overlaid it onto a Google Earth map. To that end, we are at the moment working with a leading pavement management system provider to develop a visualization and reporting platform, which is where all of this data that we're going to be collecting through better methods than traditional materials technician methods is going to go. What you can see here is, on the left, a Power BI style report looking at rolling temperatures. Very easy to understand what's good, what's bad, and what's mediocre. And on the right, you have a graphical representation of all of that data overlaid into a simple GIS style map. I've put up here, it works across different types of data. As this is the IAT, I probably won't focus too much on concrete and earthworks, but the value of this system is that it could be used on things like some of the RDP projects that are coming up, where there's a large mix of materials, and automated quality assurance testing can be of benefit outside of just what's done for the blacktop. So this is the meat of what I wanted to talk about today, is the innovations that Highway Data Systems has come up to try and improve health and safety on asphalt sites. This is a system we developed called Eload, and it is essentially a versatile materials management system for transmitting and recording information about materials moving from one place to another. What you can see here is essentially all the information that you get on a conventional asphalt ticket. As you can see, this is some tarmac material. The material code is here, the tonnage, the vehicle registration. This here is the time it left the plant, as well as the date it left the plant, and the plant identification. The way that this works is, as soon as a paper ticket is printed at site, at the batching plant, Highway Data Systems are sent that information digitally to our server. We then send that information down to a rugged tablet, which sits on the side of the paver. And the way that it works to build a laying record is, as soon as that material is tipped into the hopper, the banksman or the foreman or whoever has been identified as the best person presses the vehicle registration button, which drops a GPS point around which all of this material information is then collected. no need to mess around with clipboards, technicians writing down information, speaking from experience, making mistakes, and the like. Information is automatically, immediately captured. It's all GPS reference, meaning that it can be overlaid in Google Earth or pavement management systems for whatever purpose is required. So this is the first point on the data journey. I imagine that some of you may be aware of some of the hardware that we've used before, but I'm expecting that there's a fair few people who wouldn't be aware of the most recent developments that Highway Data Systems has come up with. A new system that we have developed is called ETEC, the Digital Technician. And this is moving away from some of the more cumbersome and expensive hardware that has been imported mainly from Germany previously. So a couple of things to mention about ETEC. ETEC is a magnetically mounted portable system which can act as either a paver monitoring or a roller monitoring system. On the back of these boxes are some strong magnets which you just stick onto the side of either paver or the roller, wherever is most appropriate depending on the make and the model. It starts collecting data as soon as it is plugged in to a power source, and the internal GPS tracks all the information that's coming into it without any need for any interaction. It is immediately compatible with Eload and connects so that materials information can be matched up to temperature sensor information to build a lane record. To that note, these ports on the side here are where temperature sensors are entered, or any other sensors for that matter. More on how that works just in a second. I've put a note here just saying that it's possible to move it between pavers and rollers in under 10 minutes. Some feedback that we've had from the contracting community is that one of the frustrations with our previous technology and some other technology on the market is that if you have a situation where a paver or a roller gets swapped out, breaks down, all the usual fun and games that happens on site, if you have a system that's hardwired onto that piece of plant, then it makes that system redundant when you need to bring in a replacement plant. HDS have come up with some flexible technology to make sure that that's no longer a problem. And so, as I said here, in under 10 minutes, you can swap it from either a roller to a paver, a roller to a roller, or a paver to a paver. We can also add in any number of sensors into ETEC, including stiffness measured through accelerometers on rollers, our visor system, which is a paver out temperature system, which we've developed for the Scotland 5G contract, weather stations, or just about any other type of input you so wish. So this is how it looks actually on the paver. We fit 2 infrared temperature sensors just pointing at the augers. They continuously measure the temperature of the asphalt material as it moves through the paver. ETEC and Eload sit on the side, generally speaking, so that the banksman can get access to press the relevant buttons to make the lane record. We can fit visor on top, and we can also attach weather stations there. Important points to make with regard to health and safety is there's now no technician sticking his hand in here or back here. There is an ETEC system which can be moved anywhere on the paver which is deemed safe. Some people have it on the back here so the form can get to it. Some people have it on the side of the paver which is not next to, let's say, a wall or a hedge or whatever particular crush risk there might be, or the other side of the haul road. The point about this is it's flexible and it enables people to make smarter decisions about health and safety on site as is appropriate for the situation. For the roller systems, we fit an infrared temperature sensor below the cab, which continuously monitors rolling temperatures. As I said, we can fit an accelerometer to the steel barrel if required, although we don't generally think that stiffness is 100% the best way to measure density. The ETEC system sits inside the cab, and there's a visual display for the roller driver to know whether he's achieving the required amount of passes at the correct temperature. So again, no technician moving around the roller to take rolling temperatures, which is a significant health and safety improvement. HDS have also come up with 2 proprietary laser systems for replicating straight edge and sand patch testing. The survey vehicle, as represented here, can also conduct other testing like International Roughness Index, longitudinal profile variance, and other measurements of macro texture. The important thing, obviously, by putting people into a survey vehicle and using lasers rather than the outdated rolling straight edge or sand patch test, is that there's no need for those tests, and that means no technicians walking along roads on their own, a mile or so away from the gang. No need for technicians crawling around on their hands and knees at 3 o'clock in the morning. Much better data sets. Laser testing delivers much larger data sets, which means that they're more useful in modeling. As I've mentioned already, it's much safer. And the additional advantage is that through using technology, there's also a lower cost associated with construction. On the cost side of things, although not the main focus of this conversation today, one of the main advantages for clients in using this kind of technology is that because information is relayed to contractors site operatives as construction is taking place, then they're actually able to correct mistakes as they happen, which improves the quality of construction and really saves money in the long run through reducing the requirement for remedial construction. Another piece of technology we've developed, which we're very proud of, is the Rate of Spread app. The Rate of Spread app uses an infrared camera to take a photo of the mat. And the way that it works is by differentiating between the hot HRA and the relatively cooler pre-coated chippings. Each pixel in that photo is assigned a temperature value, and by measuring the area, knowing the density of the stones, we can give a rate of spread of kilograms per meter squared, as you would do with conventional chipping trays. For anybody who's done a rate of spread test, you will know that this is a significant improvement on what happens at the moment. You don't have to walk onto the mat to do this test, meaning you don't have to get mountains of HRA stuck under your boots. You don't have to dodge a 3-pinner that's probably being rolled backwards. You don't have to worry about getting run over by this as you drop your trays in front of the chipper. And you don't have to dash about site catching up to do your laying records. The instantaneous result is a real improvement. Avoiding the hot material, site vehicles are, well, you can stand in a safe place and do this test rather than having to be interacting with 2 or 3 vehicles on the mat, let alone vehicles off the mat. And you avoid the crush risk from roller movements and also the chipper as well. So this is a little flow diagram of how all of this fits together. By using technology, we are improving health and safety, delivering automated quality assurance data and digital data as well. It starts at the batching plant through Eload. We collect information about how the road is constructed from pavers and rollers in real time. The survey vehicle collects information about regularity and surface texture. And all of this information is fed back to site operatives so that they can make smart decisions about what they're doing on site to influence and ensure that the work is conducted to the best standard possible. All this information is sent to the HDS database, where we visualize and report it through our tool and through Power BI. And from that point, we deliver data to our clients, the asphalt contractors, as well as to Tier 1 contractors, and then finally on to client organizations such as Highways England. So, why should we automate? It saves money on site and improves the longevity of assets through better construction. Most relevantly to this presentation, there's a significant improvement in health and safety by taking technicians away from potentially hazardous situations on site, in particular, the surface level testing of texture and profile. It's essential for modern asset management to collect data in the way that we are doing, rather than through the outdated methods that the industry has been using for the past, well, forever. And the main point I'd like to finish on is, don't be scared, because these are the same tests, but just done in a safer, better and cheaper way. And that's it. Thank you very much for your time and for listening.
Thank you, Rory. And we have time for some questions. If anyone wants to raise a hand or interject with a question for a few minutes. Rory, if I can just start off by how receptive are the client bodies, the local authorities, to this sort of information?
We actually started off our first contract with Norfolk County Council probably about 6 or 7 years ago. And since then, we've actually got a fair few more on board. I think particularly over the last couple of years, I think generally speaking, the industry awareness of using this kind of technology has improved, and a lot of local authorities have got on board. So we're now in East Sussex, Cheshire's East and West. We often do work in Cambridgeshire. Norfolk, as I already mentioned, I believe there are further opportunities in some other local authorities. I believe that the new contract that Surrey's released have actually mandated some of this testing. So we're finding that we are getting quite a bit of traction. Obviously more will be better, but we're moving in the right direction, certainly, because I think there are clear benefits to asset owners from specifying the use of this kind of technology.
Excellent, thank you. Any other questions? Okay, thank you very much, Rory. Excellent presentation. Some great information there, and